Today we're going to work with exponential decays and compare that to our exponential growths that we had learned about previously. So the equation for exponential decays is very similar to that of the growth. There's just one difference. So this is our function y equals a, 1 minus our rate, and to the time, and time is our power. So instead of 1 plus our rate, it's 1 minus because decay means it's going down. So with our equation, our y talks about the amount. So say we're talking about, hey, how much does this car worth? Is this car valued after 7 years? We would figure all of that math out, and then that would be our final amount. A is the initial price, or the initial value, or the initial number, okay? R is the rate in decimal form of decay. So if it's 2%, it's going to be 0.02. And then T stands for time. So the same variables and the same meanings as our exponential growth, but it's 1 minus our rate instead of 1 plus. So first we're going to discuss how we can find out if something's an exponential growth function, an exponential decay, or neither. Okay, so if something's growing and it's exponential, it's going to multiply. If something's decaying, it's going to divide. And if it's neither, that means it might not have a pattern or adding or subtracting because that's linear. So we're going to look and see what happens in these puzzles. So we're really looking at our outputs, our y, to see what happens. So as this one's going on, we see that it's going to be dividing by 3, and so that makes it a decay function. This next one, as we're going on in our pattern, we're multiplying by 2, so that means it's a growth function. The next one, we see that we're getting smaller, so it's potentially a decay, but I know for sure it's a decay because we're dividing by 4. And then our last one, as we're getting higher, okay, we're going to say, oh, is that a growth? Let's see what our pattern is. Since we're adding 7, it's a linear, so it's neither an exponential decay or growth function. Now we're going to start interpreting these functions. So this function that we're given represents the population of a town after a certain amount of years. And all they're asking for is what % does the population decrease every year. So what we're going to specifically look at is this 0.94. This is our decay model. So inside the parentheses, originally in our function, it's 1 minus our rate. So if all of that math was completed and we received 0.94, we need to know what our rate is. So let's solve for r. The first thing we do is subtract 1. So I'm left with negative r equals negative 0.06. When I divide by negative 1 to get rid of our negative sign, our rate becomes a 0.06. Now remember, your rate is always in decimal form, but they're wanting the percent. So it decreases by 6% each year of this town. This next one is very similar, but instead of a decimal, we are given a fraction. So we have this 9/10, and we're talking about the area of a coral reef in square miles. And unfortunately, that does decrease. So what % does this coral reef decrease each year? So we have that 9/10 equals that decrease rate. We just have to know the specific rate that it's decreasing at. So if I go ahead and start solving for r, or our rate, I'm subtracting 1 from both sides. I'm left with a negative 1/10 equals our negative rate. So then I go ahead and divide by negative 1, and I'm left with a positive 1/10 as our rate. Okay, now another way to put it is 1/10 this way. That's also our rate, but we need to put in a %, which is 10%. So unfortunately, the coral reef decreases the area 10% each year. Now we're going to deal with the value of a car, which is a very common thing to talk about when talking about exponential decays. This value of a car is 21,500, and it loses 12% of its value each year. So write a function that represents that. So don't forget that we have our exponential decay function, where it's a times 1 minus our rate, and then t is our power. So we just have to plug in what we know. Well, $21,500 is the initial amount that we paid for the car, and 12%, well, we have to convert that to a decimal, which is 0.12, and that's going to go in for our rate. So let's go ahead and plug in those values, and then we'll have to simplify, and we'll be done. So we have that y equals our initial value of 21,500 times 1 minus our rate, which we just figured is 0.12. We turn that into a decimal, that percent, and then t is to our power. So now we just have to simplify, which is just 1 minus 12 hundredths. So when we go ahead and simplify, we are given this final function, 21,500 times 0.88 t, and that is what we get. So now the next part says graph the function and then use the graph to estimate the value of the car after 6 years. So what I want you guys to do is create an XY chart. You can't do negatives. It makes no sense because we cannot have a negative time. So when we're plugging in numbers for X, I say let's just do the first 3 years, okay? Then you guys will have to find the value of the car after 6 years. So when you plug in a 6, that gives you a whole different number. So go ahead and plug those in, graph it, and come back and see if your answer looks like mine. All right, so these are the answers you should have received. Obviously, your value should be going down. That's what exponential decay is all about. So go ahead and match your numbers with mine. Make sure that you also rounded to the hundredths place because we're talking about money. You should have 2 decimal places. And then after 6 years, we see that the car that was once $21,500 valued goes down to $9,984.69. Go ahead and do the next one on your own. It's the same car that's worth $21,500 when we first bought it, but now it loses 9% of its value every year. So write that function that represents that situation, then graph the function, and then find the value of the car after 12 years. All right, this is what your answer should look like. Now, your graph might be more condensed than mine. I kind of spread it out this time, but make sure your numbers are correct. And then after 12 years, I saw that the car was going to be worth $6,933.22.